In this lesson, you will learn about semantic kernel plugins, creating a custom plugin that enables an agent to perform live web searches. The semantic kernel is the orchestration layer that allows your AI agents to move beyond static text generation into dynamic real world execution. A plugin is essentially a wrapper for a skill or a set of functions that the agent can call when needed. Let's understand the mental model, the AI tool belt. The problem: LLMs are frozen in time. They lack access to live real world data outside their training cutoff. The solution is to create a native function plugin that executes live web searches. The LLM acts as the brain that is reasoning, and the plugin acts as the hands for doing. Let's understand the plugin architecture and the components, their function. First component is the native function, the actual Python code. Example using the Bing search API. Second is the kernel hook component, the registration process that exposes your function to the AI. Third is the planner, the reasoning engine that decides when to invoke your plugin. Let's understand the mechanics of integration. First is the function definition. Use the @kernel underscore function decorator to expose your method to the kernel. Second is the metadata decorators. Use @kernel underscore function underscore context underscore parameter to help the LLM understand what the function does and what inputs it requires. The third one is tool calling. When the agent detects a need for live info, the kernel automatically triggers the plugin, retrieves the data, and feeds it back into the context window. Let's understand the practical task and scenario. The scenario is you are developing a financial research agent. The agent needs to verify company news using a live web search before summarizing it for the user. The tasks for you: first, install the semantic kernel Python package. Second task, define a class wave search plugin with a method get underscore search underscore results decorated with @kernel underscore function. Third task, register this plugin with the kernel. Fourth task, configure the kernel to use a planner that can invoke this plugin when a query requires current info. Let's see the solution code in Python. You have to create this Azure function using Python. So as you can see, this is the class wave search plugin. Next, let's understand the semantic kernel quick reference. First is core decorator. @kernel underscore function makes the function visible to the AI. Key class kernel, the central object that manages services, plugins, and planners. Best practice: keep functions atomic. Each plugin method should do one thing perfectly, that is search, calculate, or format. Summary is semantic kernel plugins allow your AI to escape the knowledge cutoff by providing a structured, repeatable way to interface with external tools. Pro tip for production: always provide a clear, descriptive description attribute in your @kernel underscore function decorator. The LLM relies entirely on this thing to decide whether to trigger your plugin. A vague description results in an agent that never calls your tool.